Hey everyone, let's take a look at number 5 in section 6.3. We're going to find the volume of the solid obtained by rotating the region that's enclosed by these three curves. Okay, they're all linear functions here. Of course, this last one's a vertical line. And we're going to rotate that region about the x-axis and find that volume. First thing I want to do is these two lines, I want to find out where they intersect. Obviously know where they intersect with this line, right? Just plug in x equal -1 and I'll have the y coordinate for when these curves correspondingly intersect. But these two here will intersect right when their y coordinates are equal. So 5x plus 10 equals 16 minus x. Solve that equation. Just add x obviously and subtract 10, and we see that x must be 1. So it's always important to graph this region, and that's what I've done. I've done it as carefully as I could here a little bit on graphing paper. I want to show you what I have here. So we have the graph of 16 minus x here, right? It passes through the y-axis at y equals 16. And y equals 5x plus 10. It's a line of slope 5 passing through the y-axis at y equal 10 there. And there's that point of intersection. And notice we said they intersect at x equal 1. And of course, when x is 1, both of these functions are equal to 15, right? If you replace x with 1. So that's 1 comma 15 where we're intersecting. And then remember the line x equal -1 is just a vertical line, at x equal -1. And of course, we can find out where they intersect each of these two functions by simply plugging in -1. So this function, -1, would be -5 plus 10. They intersect at -1 comma 5 down here. And up here, plugging in -1, I get 16 plus 1, 17. So -1 comma 17. At any rate, hopefully you see this triangular region. That's the region that's bounded by those three curves. And we're going to now rotate that right about the x-axis. So when I rotate this region about the x-axis, I'm not going to attempt to draw that three-dimensional solid that we get. However, I'm going to integrate what? This is a vertically simple region, so we're going to integrate from -1 to 1 here. Be the easiest way to do this. And at an arbitrary point here, x, I'm going to break this interval from -1 to 1 up into n equally spaced subintervals. And on this arbitrary interval here, we look at this corresponding rectangle and we rotate that about the x-axis. It goes back into the board here. And what were we going to get? We're going to get that washer, right? And so the axis of rotation is the x-axis, and I have my smaller radius, I call that little r, and the bigger radius, capital R. Of course, the area then is just the area of the big circle, pi big R squared, minus the area of this hole, if you will, pi little r squared. And I can factor the pi out and I get this. So what's the value of little r and big R? Well, little r is just 5x plus 10 because little r is the distance from the x-axis to the bottom of our rectangle, right? So what is this distance from here to here? That's our little r, right? And because that's the inside of that washer, right? That's forming that inside of that washer. And so that little r is just, this curve is the top part, which is 5x plus 10. Of course, the x-axis again is y equals 0. And so 5x plus 10 minus 0 is just 5x plus 10. That's little r. Big R will be from the x-axis, what, to the top. So if we go all the way to the top up here, then we're on this curve here. And so the value of big R is 16 minus x. Okay. So plugging those values in for big R and little r, big R is 16 minus x, little r is 5x plus 10. I'm going to simplify this expression. I'm going to expand this out. Remember, 16 minus x squared is 16 minus x times 16 minus x. 16 squared, 256. The inner and outer is -16x. So that gives me -32x. And then negative x quantity squared is positive x squared. And then the same thing here. I'll FOIL this out. 5x plus 10 times 5x plus 10. And then distribute the negative through. And I get -25x squared, -100x. And 10 squared is 100 multiplied by -1, -100. Combine like terms. And you can see x squared minus 25x, I get this. And so that's very helpful to certainly want to simplify this before we do any integration. All right, so that's all the setup, the pre-calculus setup, if you will. Now we are ready to integrate this, remember, from x equal -1 to 1 as this, the washers that we're integrating, these areas that we're adding up basically change from -1 to 1. So now we'll go back to that, and it looks like this. There's that simplified polynomial. Find the antiderivative is pretty easy using the power rule. Hopefully this is helpful, or this makes sense. Let me know if not. Plug in x equal 1. Plug in x equal -1. Be careful with your signs and everything. And then simplify, and I get 296 pi. Again, your problem might have slightly different functions, linear functions, but very similar in terms of setup. Okay, hope this helps.